Okay, so I popped the link to Vertex in chat. If you had arrived from a previous, if you arrived to the site and had a previous search in place, you can clear that search by just clicking the little arrow here and selecting Clear Search. And there are a number of ways to search on Vertex and a number of different data sets that are available to search. So I'm going to start with a geographic search here. And you'll see that here under the data set section, I can select any number of different data sets to work from or to search. And so here are the ARIA S1 NISAR-like GunWs that Eric will be demonstrating. There are all of the Opera S1 data. So currently this would include both the RTC and the CSLC. Then there's all of our Sentinel-1 data in granule format, and as well as Sentinel-1 bursts, which are geostationary bursts. So the granules can kind of shift a bit, and it can make it a little bit difficult to build long-term time series when your data frames are kind of moving around. So there is now this option to download bursts, which eliminates that issue and also allows you to work with smaller subsets of data. These are much smaller than a full granule. Typically, there are about 27 bursts per granule. So we'll start off with a Sentinel-1 granule search. You can search a number of different ways. If you have a shapefile, you can just download or upload that by dropping it right in here. Or if you just want to find your area of interest on the provided map, then you can click on this little tool here, and there are a number of different ways in which you can draw your area of interest. A very common way is to just draw a simple box. One word of warning: if you select to draw a polygon and start plotting points, I don't know the exact number, but you can overload the system with too many points. So if you opt to draw a polygon, just try to keep that polygon relatively simple. Okay, so once you've selected your tooltip, then you can head over here and just click your mouse button, drag and drop to draw an area of interest. And then there, you'll notice that it's populated your area of interest with some well-known text. So this can be handy if you intend to revisit this, or if you just want to quickly develop some well-known text for an area of interest. A great way to do that is to come here and just draw your area of interest and then copy this well-known text directly. There are a number of filters that you can apply to your search. So you can set a start and an end date. Those are also available right up here in the toolbar. So I will just pick some random dates here. Start and end date in 2023, maybe just a couple months worth. And then you can select a file type. So for Sentinel-1, you may be looking for the GRDHDs, or very commonly for SLCs, or if you don't select any, it will just show you everything that's available. But I'll select the SLC. You can also limit the results by beam mode for Sentinel-1. Pretty much all we're interested in is the IW, the wide beam mode, and then you can select which polarization you're interested in, or polarizations, and the orbit direction, whether it's ascending or descending. If you happen to know the path and frame, you can also filter by that. So let's just see what we've got with our current filter in place. And so you'll see that it pulled up a number of frames that all intersect with this area of interest. So some of them may barely touch the area of interest at all and not be much use to us. It could be that we really want this in almost this entire frame, and so perhaps this is the frame that we care about, and we would like to only look at that frame through time and eliminate all of these other frames from where they appear in our search results on the left here. You'll see that there are 40 scenes found in total for that time period. So with this, you can select different frames on the map here, and it will highlight the selected frame on the left here, and it will also show you some scene details here in the middle. And so if I select that frame over my area of interest, I can identify that it's on path 71 in frame 465. And so with that information, I could either click here and come and update these paths and frames here to limit it to that, or even easier, I can just click on this little gear here and set as either the start or the end path number, or as both, if I only care about that path. And so I'm going to set that to both. And I'm also going to set the frame to both. But you'll notice that it didn't update my results. You have to click the search button after changing those. And so now we have many fewer results, just this handful here. And so this is also the place where you can interact, or a place where you can interact with another ASF service, HyP, which produces on-demand processing of data. And so this little icon here, the stack of 3 squares, is the HyP logo. And you'll see that there is an on-demand queue here, as well as a download queue. And so if I just wanted to download the SLC, I'm just going to go and clear these out really quickly. Okay, if I just wanted to download the SLC, I can, that data is already available here. It doesn't need any additional processing. So all I have to do is click the plus button on the little shopping cart, and that will add that to my downloads here. And then I can either download that file by clicking the little link here and defining where I want to save it on my hard drive. Or if you have a long list of things to download, there is also an option to download all, or if you want to download this to a specific location other than where you happen to be working at the time, you can download a Python script that you can move anywhere and then download all of those products wherever you run that script. But if you want to order an RTC from this SLC, you would have to do that with HyP on-demand processing. So you'd click the little HyP icon here, and in this case, for this SLC, only an RTC gamma job is available, and so you can also generate InSAR products and AutoRIF products, and I'll show the InSAR. I'll give a little InSAR ordering demo as well in just a few minutes. But in this case, all that's available is the RTC gamma. So this is going to produce a radiometrically terrained corrected product. And so I can add that SLC job to my on-demand queue. However, if I had a long time series, I could perhaps have hundreds of scenes here. And if you don't want to click on all of these things individually, you can add them all in bulk right here up at the top and add all 5 SLC jobs. And you can also do the same thing for downloads if you're looking to move those SLCs into your download queue. So once you've added jobs to your on-demand queue, you can open that up. In this case, they are RTCs, so they're going to give us options available for RTC. So you can adjust the radiometry. You can either have it in gamma or sigma. You can adjust the scale. All of these are, so this defaults to gamma, power, and 30 meter, but all of these are able to be adjusted. We have found that 20 meters is kind of a sweet spot if you're looking to improve your resolution without drastically blowing up the size of your data. I'd suggest trying the 20 meter before jumping to a 10, or maybe trying just on some, if you're dealing with a lot of data, maybe just try it on a couple scenes to get a sense of what these products will give you, because we have found that that 20 meters is a bit of a sweet spot, but it defaults to 30 meters. You can also apply DEM matching or speckle filtering, and you can opt to include some additional auxiliary products here. You can include the DEM that was used for the RTC in incidence angle maps, scattering area maps, and in RGB decomposition. And so once you've gone and you've collected or selected all of your options and applied any filters that you might want to apply, then you can submit your jobs. And you'll notice right here that it says that there are 1,000 jobs left this month. So there is a quota of 1,000 jobs per month. This is something that's that the tools team is currently working on and may adjust, especially in light of the recent addition of burst availability, which are much smaller products, and so perhaps so there'll be some adjustments probably made to allow for ordering larger numbers of bursts than you would currently be able to. But that is, I believe that it's still in process, and so then I'll submit these 5 jobs. And at this point, it will ask for a project name, and I highly recommend providing a project name. It will let you submit without giving it a project name, but if you order many products and wish to use them together, it's much easier to download them as a group if you've provided them with a title project name. And so I'll just give this, RTC test. Let's give it some random name there. And so now I get this little notification that these jobs have been submitted. And if I'd like to see the status of those jobs, I can, or any jobs I've ordered in the past, I can go and look at the on-demand product search. And so this will bring up the current jobs that I have pending. Once these move out of pending, you'll see that they're running. And then when they're available, there'll be some download links here. You'll also see that I have a number of expired jobs. And so these expire after 2 weeks. The data will be available for 2 weeks, and you can either move those data somewhere more persistent, or if you need them in the future, you can always reorder them. And so you can come back here and click on the expired button, and you can resubmit the job, or you can resubmit your entire project. But I'm not going to do that. All right, and so now I'll head back to the geographic search here, and so I've got these handful of SLCs that have been that I've found, and so let's say I wanted to make an interferogram with these SLCs. We provide a search tool for that as well, and that's the baseline tool. You can either find that as one of the search types right here, the baseline, or in which, if you select the baseline, it will request a scene ID for your SLC as the reference scene for your interferogram. However, if you have found your SLC by doing a geographic search and you've selected one and you'd like to use that as your reference scene, then you can select it here on the left and then just click the baseline button here, and it will send you to a baseline search and populate that scene ID. And so here it's showing me available secondary scenes that I could use alongside the reference scene I've provided to create an interferogram. You'll notice that there are only a few here, and that is because it brought along the temporal portion of my previous geographic search. So if you'd like to build a longer time series than what your initial search allows for, all you have to do is click the baseline criteria button here and expand the time range on your search. So I can just make this a bit larger, and then when I search, you should see many more scenes populated here, and now I've got a number of additional options. And so any of these are all combinations of, these are all interferograms or potential interferograms. And so here's with the reference scene being the searched scene, and the secondary scene being the scene down in the search results here. And so if I wanted to create an interferogram between these two scenes, then I would simply select that the secondary scene that I was interested in, and once again click the HyP on-demand processing button. And now you'll notice that not only could I process this particular scene here as an RTC, but I can also select to add an SLC pair for InSAR gamma or for AutoRift. And so in this case, I will add an InSAR gamma pair. And you'll notice that the bulk option is still there. If you wanted to order all of these interferograms, you could also do that. And then if you head over to the on-demand queue, you'll see a slightly different set of processing options and filters that you can apply and auxiliary data sets that you can include. And so that is if you'd like to build individual interferograms. But if you're interested in creating a small baseline stack of interferograms to do a time series analysis, then you can also do that in a very similar manner. So select a scene, an SLC, and instead of hitting the baseline search, just hit the SBAss button here at the bottom. And of course, you can also just do an SBAss search from the drop-down menu here and provide a reference scene when asked. And so you'll see that this has provided every single possible interferometric, SLC available to make interferograms from through the entire time series, the entire S1 time series. And so right now, there are only a handful actually selected. You'll see there are only these 4 available. And once again, that's because the time frame is constricted from that geographic search. So if I want to make a very large time series, I may need to come in here and adjust the start and the end dates on this. Let's make it go all the way through current time. Okay, and so now if I search, you'll see I have a much larger network of interferograms here. And so when talking about a small baseline time series, there are 2 baselines. It's the temporal baseline and the perpendicular baseline. And so the temporal baseline refers to how long of a time elapsed between the acquisition of the reference scene and the secondary scene. And so you can adjust that with this little bar here. You'll notice that as I adjust this, if I increase the allowable limits on the temporal baseline, I get a much larger stack. And then it looks like this was the perpendicular baseline was set to 300 meters, which is the maximum allowed for by the tool and the maximum recommended. And so of course I can adjust that to whatever I want. And you'll see that as I knock this down, I lose some of these connections, and the number of pairs reflected in the side on the side search results here changes along with that. So right now there are that's still saying 4 pairs. Let's see. Oh, because only 4 pairs are selected. Okay, and so, okay, so it looks like maybe this is not quite up to date with the search, what it's saying here. But if you look here in the on-demand results, there are 1,400 or 1,413 SLC pairs representing, interferograms that we can process here. And so, that's more than my HyP quota would allow for. So in this case, I'm definitely going to have to reduce the size of my stack one way or another. in order to process all of those. And so I'm still a little bit over, so maybe I could make the time a little bit shorter. You can also do a seasonal search. So this might be something that's important if you're doing an SBAS, if you're building an SBAS stack over an area that experiences a lot of seasonal change, like freezing or vegetative growth. There may be certain seasons that you want to skip because they would cause decorrelation in your data. And so you can adjust a season here, or you can define a season rather, and you'll see that now the stack is broken up. It's no longer a connected stack, and that is also a problem for if you're building an SBAS stack in order to do an SBAS time series. So if you create seasonal stacks like this, you'll probably also need to add some custom pairs. And so the way that you do that is by clicking the little plus button up here under where it says custom pair, and then I can select a reference scene and a secondary scene, and it will build these additional pairs, skipping over, so these are long, have a much longer temporal baseline, but they're skipping over seasons which cause decorrelation potentially. And so you could do this to, connecting your entire stack, and then once again, order these individually or as a group. So I could add all 313 to my on-demand queue. And then I could select my, whatever options I wanted, and then submit those jobs and define a project name. You'll notice that there is a set MintPy options here. If you're planning to do an SBAS time series with MintPy, clicking this button will ensure that you're downloading the needed auxiliary data. You need those look vectors in the DEM in order to run MintPy. And so I'm not actually going to submit these jobs, but if I were, I would just come here and provide a new project name and then click the submit button. And then before we leave Vertex, I'd also like to show, we are covering Opera during this workshop. So I'd like to show the Opera data and also quickly the Sentinel-1 burst search. So I guess S1 burst is first on the list here, so we'll just grab that. And I'm just going to leave, you'll see that there are no results, and that is because the time period that I have selected is from is inside of 2023, and these data start currently in the archive in October of 2024. And so if I have to change the end date first in order for it to allow the earlier date. So I'll put in January 23rd, and then for the start date, I'll just start it in October. And so now we should actually get some results. Here we go. And so here are all of those bursts, and you can see there are many more bursts than what we had, than the number of scenes that we had, because the bursts are much smaller subsets. And so you can select these bursts and download them by adding them to your download queue here. At some point in the future, we also plan to have available InSAR burst processing, but that's not quite available yet. The other search that it would be good to go over is the Opera S1 search. And so this is going to have a similar, both of these data sets were released pretty close together. They're not necessarily related at all, but their data both start in October. So just be aware that if you're searching for Opera data currently, you'll only be able to look for RTC and CSLC going forward from October. However, the CSLC, am I speaking correctly? Anybody who knows differently, please correct me if I'm wrong in chat, because I often mix these two up. But I believe that the CSLC product is going to be processed for the full-time series, but is confined to North America. However, those older data products hasn't been back processed yet. So we only have data available going forward. Okay, so if I search the same area for opera data, let's see what we have. All right, and we have a set of opera bursts. And so one thing to notice is that these are like the S1 bursts, opera data are delivered as bursts. So these are geostationary bursts. And if we look at the filters, you'll see here that there are, I'm getting both CSLC and RTC products. And if I come to the filters here, I can select a file type, and there are 4 available. There's the RTC, CSLC, and then the static products for each of those. So the RTC static layers and the CSLC static layers. And so I could limit these to just, the RTC if that's what I was curious about. And then and now I've got only the RTC data. And once again, I could add those individually to my shopping cart here or in bulk.